Okay, what's up, everybody? Vin here from Vin Teaches Math. Just want to first thank everybody here who made it to the stream. This is day 3. So far, I've streamed Algebra 1, Geometry, and now we're doing Algebra 2. And the test that we're going to be going through here is the June 2018 test. So once again, whoever's here, thank you so much for choosing this stream here. It's been a fun few days, a bit tiring, but let's just get through this here. We got one more Regents to go. And just know here, once again, I'm just very happy that this live stream has gone as far as, as close as Staten Island. So shout out to any other Staten Islanders here, to the 5 boroughs. And I even had people as far as Buffalo tuning in. So wherever you are in New York State, just thank you for choosing the stream. Okay, so let's take a look. So what I'm going to do is I'm going to do a mix of calculator and no calculator stuff, because ultimately, like, you get a calculator for this test. So if you want to maximize your score, just stick to what's most reliable here. So no matter what, if we use calculator or no calculator, the first thing that jumps out at me is, well, we're solving this system of equations and we want one solution. The first thing I would do is take y plus 3 equals x, and I would solve it for x. I would solve it for y. So I just go minus 3 on both sides. And now that gives me y equals x minus 3 like this. So let's pretend it's free response. If we're in the free response, now they both equations say y equals. So what that allows us to do is we could set these equations equal to each other. And once we set these equal to each other, we're going to have x squared plus 4x minus 1 equals the new equation here solved for y is just x minus 3. So now I'm going minus x, and I'm doing plus 3 on both sides. Okay, the goal here is to make the right side equal to 0. And what I'm left with now is I have x squared, I have plus 3x, because I'm doing 4x minus 1x is 3x, and I'm doing negative 1 plus 3 is plus 2, and this is equal to 0. So now I just need two numbers that have a sum of 3 and that have a product of positive 2. So if I was going to break this down, this would be x plus 2 times x plus 1. Set this equal to 0, and this is true when either factor here could be 0. So I set each factor individually equal to 0. And this would give me x equals negative 2 and x equals negative 1. But what you'll notice here is the only two answer choices that are possible are 2 and 4, because they're the only one that have an x coordinate that matches what we have here. So if we were going to do all of this by hand, then we would have to plug back in here. But we do have a calculator, and let's just see. If we plug in, let's say, to this linear equation here, y equals x is, let's say, negative 1. Negative 1 minus 3 is negative 4. So when x is negative 1, y should be negative 4, which matches choice 2. Okay, so that's why choice 2 is good. If you were to plug in negative 2 minus 3 is negative 5, not negative 1. So that's why this is no good. But once again, you get a calculator. So honestly, I would just go to y equals, and I would type in x squared plus 4x, and let me make sure I type it correctly. So plus 4x minus 1, and then we solved for y, and it was x minus 3. So when we get to this part here, we just press graph, and notice those are the two solutions. We press second graph to pull up the table, and notice when x was negative 1, y was negative 4. When x is negative 2, so let's just scroll over more. At negative 2, y is negative 5. Okay, so if this said negative 2, negative 5, then we would be in business. But that's not the case. So choice 2 is our answer. All right. Oh, maybe someone say something here in the chat, just so I know. Oh, here we go. People are... and yeah, shout out to the people who were here for... who just took geometry. I'm not allowed to really get into the test until they release it on the Regents website, but I'm doing June 2018 Algebra 2. All right. If you just the right answer on short response, you get. Oh yeah. So I could answer, yeah, of course, individual questions. So I'm going to pull up a rubric just to show you, how they score your test. I mean, I have to grade Regents like all the time. Let's see. So, all right, something like 27. I'm just going to screenshot the rubric for this test. So if I screenshot this, notice this is a theme. I never want to hear that somebody left a question blank that you could solve with a calculator, because notice option 1 here. So I don't know why this is not behaving. Let's try this again. There we go. Especially this part. If you notice, no work shown. Okay, so if you solve questions but you show no work, and there's like they say do it algebraically, but you just do it, like you get 1 out of 2 points. Okay, if it's a 4-point question, so let me just look for a 4-point question. So for a 4-point question, let's see. Oh, here we go. So like something like question 33. What do you see this one? So 4-point question. This is even cooler. So on the 4-point questions, let's say they're like, hey, do algebra. And you say, no, thank you. I don't want to do algebra, even though you're at the Algebra Regents. Well, what happens here is if you show work, but you use something other than algebra, you get half credit. You get 2 out of 4. So that's a pretty fair deal, you know? So if you get really good with the calculator, you'd be surprised like how far that could carry you on the test. All right, now if you just know question 2, what 1/8 x looks like, this is exponential, but it's, you know, exponential decay. It's gonna look something, let's draw that way better. That was a terrible drawing. Okay, so this would be what 1/8 x looks like. This graph is always increasing is not true. This graph is always decreasing. The graph passes through 1, 0. That's not true. It passes through 0, 1. Okay, so this one is out. And the graph has an asymptote at x equals 0. This one is a very dangerous bear trap. Okay, the asymptote would actually be at the x-axis or the y equals 0 line. Okay, so if this said y, then we would be in business. But that's not the case. So it's going to be choice 2. Okay. Oh, I'm glad at Dave Braun that the geometry Regents went well. Yeah. So, oh no, at Morgan. I mean, look, you're more than welcome to play Call of Duty. Maybe if I hit like, how many subscribers do we have? If I hit like 30,000 subscribers, like I'll do a round of Call of Duty. So motivation. You could just play Call of Duty theoretically. That's the beauty of life. There are some kids right now not studying at all for this, and they're just going to show up and wing it. And, you know, they may do well, they may not do well. So that's the beauty. Like, you have the choice. I can say, because I'm not naming any students that I've worked with, but I've went to college with kids who, for all of college, they just played Mario Galaxy. And because of that, they had to drop out. So, yeah. How do you cope? So, Little Rat, I'm sorry that you didn't do well. Honestly, I have a video on how to like bounce back from failure. So it's like like you just have to go through the bad part. You know, it's like kind of like you're going through like the 5 stages of grief, however many stages of grief there are. I'm just sorry to hear you didn't do well. But you know, I say in the video, I'm like, you got to reflect on it. You got to ask yourself, like, why didn't you do well? Did you try so hard all year, or was there something maybe you could do better? And then next year you just show up better. You know, like that's really it. I wasn't my best student until like my college years. So, you know, just know like there's still plenty of time for all of you. So yeah, it's all right. You fail, you go for it again. Like I've failed tests before, and now I'm like a math YouTuber. You know, I could say I'm not the smartest math person in the world. Like I'm good at math, especially high school level math. I'm like very comfortable with, but it just takes a lot of practice. When I really hit next level, it was because I spent so much every day practicing. All right, so this one here I'm factoring by grouping. So I take out the greatest common factor of the first 2 terms is x squared. Then I take out a -9. And then notice that there's a common x plus 2. So we have this. And now if I factor out x plus 2, I'm left with x squared minus 9. And in simplest form, okay, so this is like very dangerous here because this answer choice looks like a almost good answer choice. So let's say now I factor the bottom stuff. So this, I'm going to take out, so I have x to the third minus x squared minus 6x. I take out an x, and I've got x squared minus x minus 6. And now this will factor to, we need 2 numbers that have a sum of -1 and a product of -6. So that would be -3 and +2. And let's say from this step here, like we do the algebra, and now we're like, all right, x squared minus 9 over x plus 2 over, so that's the top factored, and the bottom factored to x minus 3, x plus 2. Now this would be very devastating. You do this and you're like choice 4, but choice 4 is another bear trap. Simplest form, notice this is a difference of 2 squares. So the top could be factored even, even further, would be x plus 3, x minus 3 over x times x minus 3. And now these cancel, okay? And you get x plus 3 over x. Now, if you want to be sure, you can do long division for this, but the only thing annoying about that is that like they have matching powers. So you're going to get something weird that's not even going to look like this. All right, so you're still going to have to do algebra after that. So that just comes with experience of like seeing that. But let's say, it's the Regents, and you're like, oh no, I have 3 hours. I just want to get this correct. Press alpha y equals enter. I'll do that again. Alpha y equals enter to make a fraction. And you just type in don't press second, press x to the third. And now we've got plus 2x squared. So what are we up to? All right, plus 2x squared. Yeah, I know this is like a much smaller Regents. So just for one, like be proud of yourselves that you're even taking this Regents, because this means that you've like grinded your way through the other Regents. So awesome work by everybody. Yeah, so x to the third. Yeah, that one I would just, once again, I would just factor. So x squared and then minus 6x. So choice 3 and choice 4 both give us the same, like, are both correct in a way, but choice 3 is better because it's simplified. So choice 4 is like just not in simplest form, but it's equivalent. So you see here, like we graph it and they overlap completely. If I press second graph, see how everything matches here? So they all match. All right, if you don't like fractions, just press mode and go from auto to decimal. Okay, so that's question 3. Cool. If you like long division, do long division. Me personally, I just like to factor if possible. All right, this one you could common sense. So basically you want an equation that could like get close to this. So this one is no good because it looks exponential decay. So you see how this is like kind of like exponential increase. All right, let me try that again. So exponential increase like this. These I could tell, like, so this one's out because it's decay. These are out because those bases, like 4, like these increase like too quickly. Okay, so this is just me doing it in my head, but I'll show you why this is like no good. So these increase too quickly because this means like basically multiply the previous y value by 4. So it's like quadrupling every time. This would increase like very, very quickly. Okay, and so with this, if you double it, almost double it every time, like let's say here you're at 5, and then a moment later you would be at 10. And then 10 times 2, if you double it again, you're at 20. So you see how like this is not steep enough. Okay, so that's how I'm just doing this in my head, and I know it's choice 2. Otherwise, once again, you just go to the calculator and you're going to type in the function 1.4t, but you're going to put x, 1.4 to the x, and you're going to press plus 2. Now, what will most likely happen here, you're like, oh, I can't really see things too well. But you can even see here like 5, 10, 15, 20, 25, 30, and we're at 1, 2, 3, 4, 5, 6, 7, 8, 9. Like going out to 9, we should be like in the neighborhood of 30. But you see how like, oh no, I don't have any graph. So I would just go to window and switch the y maximum to 30. And you see how now like it captures the whole picture. Okay, so that's how I know like this is good. If I were to do one of the answers that like was incorrect, like let's say 4 to the t plus 5. So I do like 4 to the x and then plus 5 on the outside like this. It's going to fly off the page. See, it's like way too quick. It goes up way, way, way too fast. Like it's not covering any of the space over here. All right, so that's why choice 2 is our answer. All right, all of us have it tomorrow. Yes, good luck to all of you. So we will continue on. Wow, we have 115 people on. Geometry was like really massive, but that's like a very popular test. Like, I don't know, for some reason, geometry, I think, in the chat, tell me, what do you think? Do you think geometry is worse than algebra 2 if you already took geometry? You only need 28 points. Yes. So right now we're like at almost 10 points. So we're making great progress. This one, let's see. This we have to just do by brute force. Okay, so we've got x plus 3i times x plus 3i. And then minus, I'm going to change colors, we're doing, 2x minus 3i times 2x minus 3i. So we have to know how to square a binomial. Please don't ever say this. Like, I get this all the time. Don't say this. This is like, no, don't ever do that. Okay? Like, please don't ever say that. All right, you actually have to expand it like the painful way. So this is now equal to, so we will work this out. And one thing to be mindful of, I squared is -1. So just keep that in mind. So x times x is x squared. Then we have plus 3xi. So plus 3xi. Plus we distribute the 3i, we get 3xi again. Because I'm doing 3 times I times x, that's 3xi. And then I have 9i times 9. I'm sorry, 3i times 3i is 9i squared. Okay, but here it is. I squared equals -1. So I already see like this is going to switch in a moment. Okay, now the pink stuff here, I'm going to put our minus, and I'll throw a bracket. So we're going to have 2x times 2x is 4x squared. We're going to have minus 2x times minus 3i is minus 6i. So minus 6i minus another 6i when we distribute this. And now we have plus 9i squared. Okay, so I ran out of real estate a little bit here, but I'll do my best to keep this nice. So now this simplifies to x squared plus 6xi. 9 times -1 will make minus 9. Okay, so remember, I squared is equal to -1. And now we have minus, so we simplify the stuff inside here. And we've got 4x squared minus 12i. And then 9 times, this is once again -1. We're using this identity here. 9 times -1 is minus 9 like this. So then we simplify. And here we go. So we've got x squared plus 6xi minus 9. Distribute the minus, you get minus 4x squared plus 12. Oh, nobody yelled at me. It was 2x times 3 minus 3i. So there was supposed to be x's attached here. Okay, so that's minus 12xi. All right, it's okay if like you like forget things along the way. I should have a thing like down the line. If I make a little mistake like that and catch it, like, I don't know, I gotta like take a bite out of an onion or something as punishment. But it happens. Like, as long as you're able to catch your little blunders, you're fine. Like, I knew something was up. I knew that I should have had xi terms here. So once again, it was 2x times minus 3i. So I have minus 6x and I. Okay, so little like temporary blunder, but we caught it. So now we have minus 12xi is plus 12xi. And then minus 9 becomes plus 9. Plus 9 minus 9 is gone. We have x squared minus 4x squared is minus 3x squared. And we've got 6xi plus 12xi is plus 18xi. So now we scan, and this is looking like choice 3, as long as I didn't blunder anywhere, and we are good. Okay. Geometry was tough. Yeah. The triangle proofs usually depress people. So I know, just be on the lookout for those. All right. Even has y-axis symmetry. That's all I think about. And then just graph these. This I already know is odd. And just know odd is like upside down symmetry. Okay, what that means is if I take, like, let's say sine of x, and I flip this graph upside down, it's the same graph. So let me see if I could group this. Group. Okay, yeah, if I flip it upside down, you see how it's still a sine curve? That's what makes it odd, but not even. It doesn't have y-axis symmetry. It's an odd function. This one looks good. X squared minus 4 looks like this. Okay, so there's that y-axis symmetry. So that one's looking good, but let's see why the others are no good. This one is almost good except for this part. This ruins it. Okay, so this ruins like the this ruins like yeah, this ruins it. Okay, we'll just say this ruins it because it's like taking let's see, if I go here like this, so there's absolute value. It's like I take absolute value and I move it to the right 2 and up 5. So you see it doesn't have y-axis symmetry. It has x equals 2 symmetry. Like if we want to be like really cool here, we could say, hey, at x equals 2 we have a line of symmetry, but that's not the y-axis. So that's gone. And then this, use a calculator. That's not it. Choice 2. Cool. All right. So this one here, I would just graph. Okay, but if you like are like savvy with this, you might recognize that this is like 100 over e to the 0.023t like this. Okay, so this would be exponential decay. I think they even tell you here, the sample function models the number of grams in a sample of this that remain after t years. What is the samples, on which intervals, on which interval is the sample average rate of decay the fastest? So when is it decreasing the fastest? So if it's exponential decay, you could just graph this. It's going to look like this. Okay, so let me just fix that a little bit. All right, so I would say here, like from 1 to 10 is going to be when it decreases the fastest. Okay, because you could see like 1 to 10, like let's say 10 is here, like 10 to 20, it's like flattening out. Okay, it's not as steep, so it's not decreasing as fast. 15 to 25 also is like not as steep. See, like 15 to 25 is like pretty flat compared to like this one here, which I'll do in black. Okay, let me change colors. So like, see that secant line, like when I draw that in, that's like way steeper like of a decline than like from 10 to 20. Like see, 10 to 20 is like not as steep. Okay, 15 to 20, not as steep. Like 1 to 30, like at 30, it's like way lower. It's like not as steep. Okay, it's like flatter. All right, so that's just something to be mindful of. If you're like, wait, how'd you graph that without a calculator? All I'm doing is, you know, like 100. E is second. So second ln, and it's e to the negative 0.023. So negative 0.023, and we tack on the variable like this. All right, and then you press graph, and you're like, oh no, I don't see anything. And that's because we're starting at 100. So our initial value is at 100, so make the y maximum really high. Okay, and you see how it's going out to like a maximum of 30. So make your x maximum go out to 30, and you'll be able to see what's up, like, you know, what's happening here. See? So that gives you like the piece. You only need 2 credits for math to graduate. No, most schools it's 6. But you're actually going to fail. Oh no, like for real. Hang in there. Remember, this is just a test. You know, you always have the option, like you could show up tomorrow and just like eat the Regents and leave, and you would still be you. I don't recommend it, but like that's always an option. So like it's just a test. You know, I know it's like, oh, but it means a lot. Like worst comes to worst, you just take it again, or you don't. Like, but you'll still be you. So, you know, hang in there. So this one, it helps if you could expand really quickly. So x times x is x squared. You've got x times negative 1 is minus x. And then you got plus 7x. And then you got minus 7. Okay, so this is x squared plus 6x minus 7. And then these, you just expand. And let's see which one matches. So this one is x squared plus 6x plus 9 when we expand this. But then we just have a minus 16. Okay, so minus 16 like that. And this is going to work out to x squared plus 6x minus 7. Yeah, this one matches. Choice 1. Okay, if you really want to be sure, like you could mess with the others here. And, you know, you could see like how they all work out and like how it's not the same. This one, you want to see some sorcery? All right, here we go. Here's some craziness. So this is x plus 3 squared. Let's see. These are like terms. So they're sneaky like terms. But minus 10x plus 3 minus 2x plus 3 would be minus 12x plus 3s. And then we just tack on the plus 20. Okay, so what I'm imagining here is like, I'm imagining it says like u squared minus 12u plus 20. And then this would factor in minus 10 minus 2. But instead it would be x plus 3 minus 10 times x plus 3 minus 2. So this would actually work out to x minus 7 times x plus 1. So it's like almost matching, but not quite. All right, otherwise just expand it and see if it matches. Multiple choice is 2 points. Okay, slow down. Oh, sorry, bud. Yeah, I'm only moving a little bit fast here because I'm starting to feel like really just burned out. This is like day 3 in a row. So yeah, I'm doing my best here too, but I'll slow it down a little bit if people prefer. Or no, let's vote. Who wants me to go slower? Who wants me to go super fast? All right, now this one, what I like to do is say what x is not allowed to equal. So x is not allowed to equal anything that makes the denominator 0. Like denominator equals 0 equals bad. Okay, we don't want that. So like if x equals 0, that's bad because that's a denominator. If x plus 3 equals 0, it's really bad if x equals negative 3. So I say x is not allowed to be negative 3 or 0. But notice that's not an answer choice. So like sometimes it is an answer choice and you have to omit it at my own pace. Yeah, I mean, you could always rewind and listen to me again. So slow. Oh yeah, here we go. We're voting. Slow, 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 fast, fast. Oh wow, okay. Slow, slow, fast, slow, 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 slow. Okay, I'm going too fast a little bit. All right. Yeah, I guess I'm cruising through. Geometry, I took like the full 3 hours. So I guess I was trying to just get them a little faster, but all right, I will listen to the people. So 2 over x minus 3x over x plus 3 equals x over x plus 3. What you want here is you want to think of the least common denominator, which in this case is x plus 3. So there's a few ways you could do this, but one way I like to do these is to make the denominators like just disappear. Okay, so what I would do here is multiply everything by x times x plus 3. So like I'm multiplying this by x plus 3. I'm multiplying this by x times x plus 3. And I'm multiplying this by x plus 3. And watch what happens. X over x is gone. X plus 3 over x plus 3 is gone. X plus 3 over x plus 3 is gone. And now just multiply what's left. So you see what you got? You got 2 times x plus 3 minus 3x times x is 3x squared equals x times x is left is x squared. And now distribute. So this gives you 2x plus 6 minus 3x squared equals x squared. So now solve this equation. You just now combine stuff here, combine like terms. So I could subtract the x squared over, or I could move everything from here to the other side. So go plus 3x squared on both sides, go minus 2x on both sides, and go minus 6 on both sides. So see you later, see you later, see you later. 0 equals 4x squared minus 2x minus 6. So just making sure that I'm up to the correct step. So 4x squared minus 2x minus 6. We are good. Now here I could use AC method, or I could factor out a greatest common factor. So I'd say 0 equals 2 times 2x squared minus x minus 3. And now I think AC. So A is equal to 2, and my C term is equal to negative 3. A times C, 2 times negative 3 is negative 6. My middle term B has a coefficient of negative 1, and I say what two numbers multiply to negative 6 and add to this would be negative 3 and 2. So then I break this up. So 0 equals 2 times, we've got 2x squared, let's fix that, minus 3x plus 2x minus 3, and this equals 0. So now just factor by grouping. And the 2 I could just start to ignore now. Like just think of it as like, this doesn't give me anything, but whatever, I'll keep writing it. And that's going to give me, take out an x, and I got 2x minus 3. And take out a 1, and I have 2x minus 3. So now this is 0 equals 2 times x plus 1 times 2x minus 3. And from here, this is going to give me x plus 1 equals 0, and 2x minus 3 equals 0. X equals negative 1, and x equals 3 halves. So negative 1 and 3 halves, choice 4. Okay, so algebra. Okay, be good at algebra. It is the algebra Regents. The second one too. All right, just know you could also, if you want, this is like a sneakier way, but you could always type in the question like this. You could say, all right, alpha y equals enter 2 over x minus 3x over x plus 3. And this is equal to x over x plus 3. So x over x plus 3. And what you could do is, I'm going to press second window, switch independent from auto to ask. And now go to the table and just start typing in answers. Say like, is 3 an answer? And they should match. Like, no, they don't match. You're like, okay, is 3 over 2 an answer? Like, yes, they match. So 3 over 2 works. So like this is out. And now let's see, oh, does -1 work? Like, yay, they match. So calculator, that's a calculator trick for you. Okay, so, this one. All right, let's see. So this one, you got to know your trig graphs. But once again, you could just type everything in. Okay, if you want to do this, that's an option. If you want to do it the fancy way, you look for the midline. Okay, the midline is either 5 or 9. 9 is looking better. Let's see, 2, 4, 6, 8, 9. So the midline would be here. So it's either sine or cosine. So like when you have like y equals a sine, and these all look like kind of like bx and then plus c. This is the midline. This is the frequency. And this is the amplitude. Okay? So the midline is 9. See, that's the line of symmetry, the horizontal line. So like this is gone and this is gone. Now you're like, oh wait, they have the same amplitude. See, like if this is 9, if I go 9 plus 5, that puts me at 14. If I do 9 minus 5, that puts me down here at 4. So like the amplitude is the distance from the midline to either the top or the bottom. So it's like, oh no, which one is it? But if it starts on the midline at 0, then it's a sine curve. Okay, if it was a cosine curve, it would have started like, cosine would have started up here. So it would have gone here, and then it would have went to like the midline, and then it would have went down like this. And then it would have went back to the midline, and then it would have went like, yeah, so like for the significant values, it would look something like this. All right, like that's how it would look if it was this choice. But it didn't start at the max. It started at the midline, so it's sine. But otherwise, like you're like, wait, how do I know for sure? Type in the calculator. Okay, so this is nicer though. This is like style points. Okay, so that's style points. This is brute force. But they both work and they both get full credit. So yeah. You get a point in the short response. Yes, if you solve something without algebra when they ask you to, you will get a point. Okay, so Nick will oversleep, 48% chance. The probability he has a pop quiz is 25%. So assuming these events are independent, what is the probability that Nick oversleeps and has a pop quiz? So that just means multiply these. Okay, so here that's 48 out of 100. And 25% is 25 out of 100. So for this, let me just see. How is this going to work out nice? Oh, I think I see it. Okay. So here, the probability that Nick oversleeps and has a pop quiz, we multiply the probability that he has a that he oversleeps by the probability he has a pop quiz. So we're doing 48 out of 100 times 25 out of 100, which is calculator. All right, if you want to be really slick, ready for this? So no calculator, style points. Divide top and bottom by 4. That's 12 over 25 times 25 over 100. 25 over 25 cancels. This is 12 over 100. And 12 over 100 is 12%. Okay, so 12%. All right, that's way cooler. If you do that plus 5. Don't trust me. I'm just a piano player. I mean, if you just want to pass, I guess you just need to do what you need to pass. But if you want to get a great score, like you get a 95% on the multiple choice, like chances are you're going to do well in the free response. So yeah, just be mindful of that. All right, I'm going to take a quick commercial break. So here comes an ad. Did that work? Wait. Oh, I got to enable monetization. I thought I enabled monetization. Let's see. Monetization is enabled. I thought it would have worked. Let's see. Let's try that again. Insert ed. All right. I guess I'm sorry if I'm... Okay, whatever. We'll just continue. So here, I'll take a sip of water. Yeah, I'm just kind of burnt out a little bit. So you have to excuse me. I was like so tempted to just fall asleep, but I didn't want to leave everybody hanging. You know, I'm really doing my best. And once again, I'm just really grateful to have you all on. I don't care like how big the live stream is. Like even if I have just one person on, like I see it as worth my time to help grow my channel. So thank you for being a part of it and helping me grow this channel. If you have not subscribed yet, please consider pressing subscribe. Okay? Cool. So x minus 1 is a factor of this. Whoops, don't cross it out. It's a factor of this. What is the value of k? All right, let's say this. F of x equals this. If x minus 1 is a factor, that means I would have like x minus 1 I could set equal to 0. That means x equals 1 is a root. Okay, this is from Algebra 1. But factors and roots have an opposite relationship. Okay, they are opposites. So I use that idea for questions like this. Okay, because what that tells me, if x equals 1 is a root, then f of 1 is going to be equal to 0. All right, but if I plug in 1, I get 1 to the third minus k times 1 squared plus 2 times 1, and this has to be 0. So this gives me 1 minus k plus 2 equals 0, which gives me 3 minus k equals 0, and k would have to be 3. So choice 3. Cool. Yeah, sorry everybody. I am feeling a little bit fried, so I do have to just like kind of power through here. So I apologize if that makes it hard to follow, but yeah, I'm just feeling like definitely like a bit burnt out right now. So it's been a long few days, like going to work and then live streaming for 3 hours, like a few days in a row. It's not been pleasant. All right. So let's see. Profit function is the cost function subtracted from revenue. So profit equals revenue minus cost. Cool. So just put this in words. The profit function P of x is this. Okay, so now just substitute. Negative 0.5 x squared plus 250x minus 300 equals, we want to know what the cost function is. So you see that, like the cost function is means we're solving for this piece. So what is c of x? So it's equal to r of x minus c of x. I'm sorry, profit equals revenue minus cost, but we're solving for c of x. So now we just have to plug in for r of x is negative 0.3 x squared plus 150x. And remember, minus c of x. Okay, so we're going from here to here by, you know, substituting. And then algebra, you're at the algebra Regents, so do some algebra. So plus 0.3 x squared here, plus 0.3 x squared, minus 150x, minus 150x. And now this is going to give you negative, this is like negative 5 plus 3 is negative 2, but just put a decimal 2. X squared, 250 minus 150 is 100. Minus 300, but be careful here. Okay, gone, minus c of x. So this answer choice here is like LOL. Okay, don't pick this. All right, you have to get rid of that negative. So just multiply everything by negative 1. And then c of x, this gives you just positive c of x equals, everything changes signs, 0.2x squared minus 100x plus 300. Okay, so that is choice 1. Yep, cool. Did you have to do physics lab? Yeah, you have to have your labs in. I used to teach physics also, but I haven't taught physics in like 4 years. I was like playing with the idea. Down the line, I will live stream for physics, but I don't think I could do it this week. Sorry to give people false hope. Okay, so let's see. What do we got here? It's the populations of 2 small towns beginning 2018, and their annual population growth rate are shown in the table. Assuming the trend continues, approximately how many years after the beginning of 2018 will it take for the populations to be equal? Oh, so we have to just make an equation for this. So just know a 6% increase. I'm just thinking like, my head goes here. It's like, 1 plus r, like that would be like 6% is 0.06. So I'm doing like 1 plus 0.06 to the t power. Like if you want a formula, like a equals p times 1 plus or minus r to the t power. All right, and be mindful, it is an annual population growth rate. So it's only once per year. Like don't worry about this formula. Like you're like, hey, what about this one? Like the r over n to the nt. Like in this case, it's like n equals 1. So we get to do like this is the nice one. This is like the easiest. Okay, and then like this one is like not as nice. And then this one is like a little bit tricky, but in the same neighborhood. This is like continuous. Okay, so continuous growth. Then you use this. Okay, but what I'm doing here, I'll call it J of t for like the growth of Jonesville, is I'm using this formula here. The initial population is 1240. And now I'm doing 1 plus because it's population growth, not decay. So population growth, I'm going to have 1.06 to the t power. And then Williamstown, I'll call W of t. Initial population 890. And now 11%, just know, is 0.11. So this is 1 plus 0.11, or 1.11 to the t. And now just set those equal. All right, you could do algebra here, but you have a calculator. Like, don't do that to yourself. So I'll just go to the calculator. And let's see, scroll down a bit. J of t was 1240. 1240 times 1.06 to the t power. And then this one was 890. So clear that. 890 times 1.11. Don't hit 9. Parenthesis to the power t. All right, now remember, this is in independent mode. If you missed this part of the video, press second window, switch independent from its preset on auto. You could set it to ask. Okay, and now second graph, you go to the table and just typing in start typing in values like 7, and you're like, oh, they don't match. 20, you're like, oh, they don't match. 68. And they don't match. Let's just see. Wait, was it? Oh, you know what happened? I think they might have. What did I type in here? 1 point. Let's see. It was 1240 and 890. 1.06 to the t. 1.11 to the t power. What did I type? Something in silly here. Let me just do this. Let me go to the graph and see that if I go out. Because 7 was the closest. But why was that? I guess which one is best, but that's going to bother me. Oh, wait. Assuming approximately how many years? All right, let's see. So it was at 1864. So let me go up to 2000. So 2000. All right, I'm just thinking out loud. All right, you see how they intersect here? Press second trace. Number 5. Here we go. Enter once. Go near. Hit enter a second time. Third time. 7.19. So 7 years seems to be the one. So 7 is best. I don't like that. I wish it would have been more precise. That's why I was checking to see if I made a typo. Usually they get it way closer. So, well, whatever. Yeah, 1.11, 1.06. Okay, finding the inverse. So finding the inverse, think of this as y equals x to the third minus 2. You switch x and y, so say x equals y to the third minus 2, and then solve for y. So go plus 2. This is gone. You got x plus 2 equals y to the third, and then the opposite is to take the cube root of both sides. So y equals cube root, x plus 2 is your inverse. That's this one. Okay, so 15 is choice 3. All right. So moving on, let's see here. Ooh, I like this one. So remember we said before, roots and factors are opposites. So here, which one could be this? If we have zeros at -5, 3, I, and -I, that means like it's going to cross, this is like the x-intercepts. So just look, -5, 3, but uh-oh, see here? This is like too many roots. Okay, this means we just have 2 real roots. All right, so this is too many. Sorry, English language like kind of stinks sometimes. All right, -5 and 3. This one looks good. So just 2 real roots. Looks good. Uh-oh, see this one is -3 and 5. So that one's out. And this one, too many roots. Too many. So you're out. Okay, if you really want to be fancy here, remember we said roots and factors are opposites. So imagine like I got my solutions here. I'm like, all right, x equals -5, x equals 3, x equals I, x equals -I. I go backwards, I would have like factor x plus 5, factor x minus 3, x minus I, x plus I, and this is all equal to 0. And then I go up one more and say, all right, this times this. This I could even leave as is. Like let's say I don't know how to expand that. But this one is kind of like difference of 2 squares. So this is like style points. But this was like the easiest. It's just process of elimination. But if you want style points, that's x squared minus I squared. See, x squared minus I squared, and then I squared, remember, is -1. So then, like this was all set equal to 0. You'd have x plus 5, x minus 3, and parentheses here, of course. You'd have x squared minus -1 or +1. So if you type this into a calculator, it should look like this. Choice 2. All right, cool. Oh, 208 of you. 1,000 people stopped by. Thank you so much for supporting the live stream. I hope everybody here does well tomorrow, even the people not here, but especially all of you for supporting me, so thank you. So let's see. The weights of chocolate candies are, oh, here we go, normally distributed with a mean of 4.3 ounces, standard deviation of 0.05 ounces. What is the probability that a bag of these chocolates weighs less than 4.27? So the concept here, think of like normal distribution. That's the bell curve. And the mean, so the mean here is 4.3. So that's the average. Okay, and they're telling us the standard deviation is 0.05. So that would be like one standard deviation this way would be minus 0.05, which would give you like 4.25. And then 2 standard deviations, that would give you, let's say, 4.20. This would give you 1 standard deviation. This way would give you 4.35 when you add this. So this is like the old way we used to do this, but nowadays the calculator will do everything. So this is just the idea. When we want to know what is the probability that a bag of chocolates weighs less than 4.27, you see how like 4.27 is at an awkward spot. So that's here. Okay, so this is the probability we want. So calculator. Now I can't remember the button sequence, but I'm going to show you a trick. It's normal CDF. So I press second 0 for catalog. I could scroll to N, or I could press alpha log, and I hyperspace travel to normal CDF. I press enter, and for this one here, let me just see if I put diagnostic on. What does that do? So let's make this a little nicer, because there used to be a nicer way of seeing this where like it's all because I don't want to show this like the Neander. Oh, what did I press? Oh, hang on, let me fix that. So diagnostic on. So alpha x -1. I don't know if that affects it. I know that affects like correlation coefficient, but let's see. Because I just want it to be as easy as possible. So normal CDF. So you could just go to the catalog if you forget where things are. And normal is here. Okay, so normal CDF. Second vars for the win. Okay, normal CDF. Okay, or just scroll there. Oh yeah, and look, see, I put the diagnostic on, now everything's nice. So our lower, see here, like our lower limit would be like, how much does the weight of chocolate weigh? Like, just say 0. Okay, it weighs nothing, which wouldn't make sense, but whatever. The upper is like, what's the maximum we want it to weigh? Was 4.27. We want it to be less than or just about equal to 4.27. Okay, for this part here, this is the average. The average in this case is 4.3. And then the standard deviation was 0.05. So we just do this and press enter. And you're going to get 0.2742. Or 43, because we're going to round 5 rounds this up to a 3. So it looks like choice 2. Okay, but you can see here, like, this is also, like, this is too much. Because it's less than half. All right, so that just helps you make sense of your answer. But yeah. All right, 18. Algebra or no algebra? All right. If you want to see this with algebra, I guess why not? We'll do the algebra. So here, iodine, half-life of iodine is 8 days. The percent of the isotope left in the body d days after being introduced is this. So there's the formula. When this equation is written in terms of the number e, the base of the natural logarithm, it is equivalent to this. What is the approximate value of the constant k? So just set those equal to each other. So you're doing 100 times a half to the d over 8 equals 100 e to the kd. So first divide by 100, and this is gone. And now you got 1/2 to the d over 8. Let me fix that. So d over 8 equals e to the kd. And now natural log both sides. You could use any log you want, but I like natural log because it'll get rid of e. And then properties of logs. I'll write this over here. Those exponents inside. So these could pop out in front. Okay, so that's what we're going to do. We're going to have d over 8 times natural log of a half equals kd times natural log of e. Now, you could ask the calculator, but I promise you natural log of e is 1. So this like just kind of wipes out. And then you could divide both sides by d. So, or you know what, I won't cross it out. I'll just say this is equal to 1. Okay, but divide both sides by d. And then d over d cancels on both sides. So now what we have is we have ln of 1/2 over 8 equals k times ln e, but ln e is 1. So k times 1, which is just k. So if you want to know what is k, just type this in the calculator. Natural log of a half divided by 8. So natural log of a half, which is 0.5, and then divide by 8. Negative 0.867 or negative 0.087, which is choice 1. Cool. All right. Yeah, so once again, thank you everybody who joined. I'm doing my best here to stay strong, but yeah, I am slowly burning out. We are almost an hour into this, and yeah, I apologize. I just wasn't feeling too well. I almost took off of work today, but I didn't want to leave everybody hanging, so I'm here now. So let's see. Y equals log base 2x translated to the right 1 unit and down 1 unit. So this would be y equals log base 2. And if I want to go to the right 1 unit, I replace x with x minus 1. If I want to go down 1 unit, I go minus 1. So this, the coordinates of the x-intercept. The x-intercept is where y is equal to 0. Okay, just imagine the x-intercept is where y equals 0. So I could use a calculator, or if we really want to show, like, you know, our skills, we could set y equal to 0 and just solve. So log base 2, x minus 1, minus 1, just add 1 to both sides. And now 1 equals log base 2 of x minus 1. So remember, this is base. Let's fix that. Base. That's also sloppy. Exponent. Result. Okay, you should be fairly comfortable with, like, if you have like a to the b equals c, that this is log base a of c equals b. going from like this form to this form. Some people like to do the loop. They go like 2 to the first equals this. So they would have 2 to the first equals x minus 1, and now just add 1, and x equals 3. Okay, so 3, 0 would be it. If you want to use a calculator here, I guess what you could do is just graph this and then trace. Okay, so yeah. Oh, thank you. I know I'm so tired. I'm like debating, should I just power through? Yeah, I'm gonna take a water break. So I will press the, I don't know if it just gives everybody an ad if I press insert. Yeah, sorry if I was like way more like well rested and stuff. I would be like way more with it. And truth here also, like I'm a dad of 2. I have 2 toddlers, and they've, you know, we're like having a little trouble sleeping this week. So they don't sleep, then I don't sleep. I'm sorry. Yeah, I'm tired. I hope you're able to follow it though. Like, do we still, are we still learning this year? I hope so. All right. So let's see. All right. For positive values of x, which expression is equivalent to this? So here, what I would do for positive values of x puts you in this situation. Square root of x squared is usually plus or minus x, but when x is greater than 0, square root of x squared is just x. Okay, so we're just going to use that idea. So this is the same thing as like square root 16 times square root x squared times x to the 2/3 plus this is cube root of 8 times cube root of x to the 5th. And just looking at this, square root of 16 is 4 times x to the 2/3. And this is x to the 1st. So plus the cube root of 8 is 2, because 2 times 2 times 2 is 8 times cube root of x to the 5th. And here I would add, right? When you have this, a to the b times a to the c, that's a to the b plus c. So if I do 1 plus 2/3, I could calculator that, or that's 3 over 3 plus 2 over 3, which is 5 over 3. Okay, so this is 4x to the 5/3, like this, plus I'm going to call this 2x. The idea for this one, remember, this is another thing I'm thinking about. The c root of a to the b is a to the b over c. Remember, power over root. Okay, power over root. So we use that, and it's going to be to the power 5 over the root 3. And see, these are like terms. So this would just be 4 plus 2 is 6, x to the 5/3. And now send it back. This is 6 times the cube root of x to the 5th. Choice 2. All right. Here we are. Moving on. Oh no, one of these. Yeah, I'm like burning out pretty hard. All right. What I will say is I'm going to finish the multiple choice, and I'm sorry to do this, but I think I'm going to tap out after the multiple choice. I'm really like, I tried my best to stay on as long as I could, but I'm just like not like feeling 100%. So I'm going to finish this out. And yeah, I'll just say watch some of my old videos. Like I have like a ton of Algebra 2 Regents videos. If you haven't watched all of them yet, like there's plenty to keep you busy. So yeah, or just Google it. Like I'm sure someone else made it, and it's probably like decent enough that you could follow. So focus and directrix. So the concept is that a parabola, like this is the directrix and this is the focus, would open downwards like this. So the parabola is the set of all points that are the same distance away from this point, the focus, and this line, the directrix. So this one you could just kind of concept your way through. So here, something like -2, 5. Let me just see. Let me make that a little lower. So -2, 5 is 1, 2, make that a little neater. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a directrix of y equals 9. So this is the, the directrix. The focus is at -2, 1, 2, 3, 4, 5. Okay, so there's the focus. So the parabola, this would be a situation where the parabola is going to look something like this. Let me just move that over a little bit so it's a little bit more lined up. Okay. So this would be the vertex. Okay, the vertex, and it's going to open downward like this. All right, if you have a situation where the directrix is under the focus, like if you have something like this, then your parabola opens upward. Okay, but the focus is under the directrix. So now just looking at this, you could just kind of count the boxes here. Remember that concept that it's the same distance? Let me fix that. This is 1, 2, 3, 4, 5, and up to 9 is 4 away, but halfway would be 7. So the vertex we could find the location of would be -2, 7. So that's our vertex, and then you want this formula, a times x minus h squared plus k, where the vertex is the point hk. So if I plug that in, I have y equals a times x minus minus 2 becomes x plus 2 squared, and then plus 7. So just looking at this, the x plus 2 should be squared. And I'm looking at that. This one, the y minus 7 is squared. So like these are out. Okay, so 21 is not going to be 1 or 2. All right, so that's just process of elimination. X plus 2 should be squared. But then you're like, oh no, which one is it? Well, if you think about it, if this opens downward, so opens downward, that means a has to be negative. Okay, those are the only parabolas where it opens downward. So here we would need a to be less than 0. So that's why this one is looking good. Like we need this to be negative, because if you start solving here, see -7 like this, and I got y minus 7 equals a times x plus 2 squared, I could call this y minus 7 in parentheses, and I could multiply both sides by 1 over a. See how a over a cancels, and now I have 1 over a times y minus 7 equals x plus 2 squared. But once again, a has to be less than 0. So in this case here, a would actually be -1/8 to make this. But we don't actually have to solve for it. Okay, we just have to use common sense, like, or process of elimination plus the definitions. All right, cool. This is June 2018. Alrighty, let's see. Which identity is true? So this one we got to suffer a little bit. So I'm doing this. So this is equal to a times a is a squared. Let me just erase this stuff. Get this out of here. Okay, so a times a times b, plus a times c, plus distribute b, you get another ab, you get b times b is b squared, and you get bc. And then one more, distribute c, and you get ac plus bc plus c squared. So here and then here. So then you combine like terms, and this tells us, I'll write it over here, x equals a squared plus b squared plus c squared. You see how there's like these three terms? But then there's repeating stuff. There's ab, so that's two ab's. Plus there's a bc and a bc, so that's two bc's. And then there's two acs. So now just look at the answer choices. They all say x equals. So then how do we combine this to build this? Well, think about it. Like I could say x equals y, that covers this stuff. See, y is like this part here, covers this. But then if I did 2 times z, that would give me 2ab plus 2bc plus 2ac. So this part here is 2z. So y plus 2z, choice 4. Cool. All right. Oh, these are fun. So these are just annoying. So a to the b to the c is a to the b times c. So for these, you could just type in the question and the answers, but they want to know which expression is equivalent to this and could be used by students to identify an approximate daily interest rate on their loans. Remember, there's 365 days per year. Okay, so we want to incorporate that. So the trick here is that d of t equals 29,400 times 1.068 to the, now I'm going to do this rule, but I'm doing this rule but backwards. You'll see why in a moment. So I'm going to write this to the 1 over 365. So you see how here I ultimately have a power t, but I'm going to raise it to the 1 over 365 times 365t. The reason being is that if I have like, I'll just write it with an a, like a to the 1 over 365 to the 365t, I just multiply, and this is a times 1 over 365 times 365 to the t, and like 365 over 365 cancels, and it brings me right back to exponent t. Okay, but then what you're doing here is this goes in the calculator. So let's go for it. 1 point, and we have here 0.68 because I forgot, to the 1 over 365 is giving us 1 point. Oh wait, actually we don't have to simplify it. Those are seconds I'm never going to get back in life. It just matches choice 4, it looks like, right? Yeah, that's choice 4. So sometimes they make you like, so forget this, but sometimes like you have to do this. Okay, but not here. Okay, all right. Last question, because yeah, once again, I'm sorry, but I got to tap out. There's no way I'm going to be doing like another hour and a half of this. I apologize, but not feeling well. I'm going to have to rest up and get better. But just watch my old videos. I have as recent as January 2023. So a manufacturing plant produces 2 different size containers of peanuts. One container weighs X ounces, the other weighs Y pounds. All right, just know this. 16 ounces equals 1 pound. Okay, remember that means pound. Sorry for the English language. Okay, 16 ounces is 1 pound. So what that tells you, if one container weighs X ounces and the other weighs Y pounds, a gift set can hold one of each size container. Which expression represents the number of gift sets needed to hold 124 ounces? So here we're taking the big amount, 124, and we're dividing it by, let's see here. So this is 124 ounces. So we want to express the weight of like one container and the other container. Remember, this is X ounces and this is Y pounds. But remember, we said a pound is 16 ounces. So that's 16 Y ounces like this, okay? Just imagine if I had like 5 pounds, that's 5 times, or I could say it like this if I really want to be fancy. 5 pounds times 16 ounces over 1 pound gives me 80 ounces. Okay, but just multiply the number of pounds by 16. That'll give you ounces. So 124 ounces divided by X ounces plus 16 Y ounces. And then units cancel. And it is going to work out to choice 1? No, choice 2. Yeah, the 16 was attached to the Y, not the X. Cool. All right, choice 3. So everybody, that is going to be it. I know 1 hour is a little bit shorter than we expected, but if you have to, use my old videos. But once again, thank you so much for joining the live stream here. I appreciate it. Yeah, I apologize once again if you're feeling let down. But I really did my best here to power through. I wanted to give up on question 5, but I was like, let me at least get them to 24. All right, so good luck tomorrow. All right, if you're nervous, just hang in there. Remember, it's just a piece of paper, a few pieces of paper. No matter how you do, you're still going to be you, and you're going to learn something about yourself. So just put your best math down on the paper, and have a good night.